So for the second video in this chapter, I'm just going to go through some more function examples to hopefully give you, just more things to work with. Looking at a function which will compute your age based on the year that you were born, the month you were born, and the day that you were born. But in order to make that computation, we actually have to know what the current date is. So I'm importing a Python package called datetime, which I found through that wonderful thing Google, and how to use it. So inside of age, first we have to, come on PyCharm, quit giving me pop-ups. Okay, so inside of age, we first compute or get what the current date is using that package datetime. And then we compare your month born with the current month. And if it's less, then you've already had a birthday this year, so this is your age. And this is a function, so we're going to return that value back to the calling code. And once this is executed, this return, that's it. We'll exit the function and go back to the calling code as soon as it hits that return statement. So all this other stuff will be ignored. If the month you were born is after the current month, then you haven't had a birthday yet. We need to subtract a year off. And if both of those fails, that means that you were born during the current month, and we now need to check the day you were born versus the current date. It's a similar computation. If the day you were born is less than or equal to the current day, then you just do this subtraction, the year you were born from the current year, that's your age. Otherwise, you have not had a birthday yet, and so we need to subtract 1 from that computation. So down below, we're going to get the current date using datetime again, and just print out the current date, the current year, the current month, and the current day, just to check that it's working correctly. Print off 3 blank lines, and then we're going to compute the age of somebody born April 12th, 1975. So the 4th month, 12th day, 1975, September 4th, 1934, and then we're going to use the current year, current month, and current day to print off the age of somebody that was born today. So let's run that. Age. And we'll run age, and we will find out that today is September 8th, 2014. And if you were born on April 12th, 1975, you are 39. September 4th, 1934, you are 80. And if you were born today, you are 0 years old. We're going to add to age. So this is the exact same age function from the previous example. But in age and generation, we're going to go back and revisit the procedure generation we had, which printed off what generation you're in, baby boomer, generation X, generation Y. And we're going to change this so that we return the value baby boomer, generation X, generation Y. And I probably should have returned baby boomer instead of baby boomer, but, well, that's the way I did it. The advantage to this is we can use these generations now inside another string that we can customize any way we want, whereas before we actually printed off you are a baby boomer and that was it. You couldn't really use it any other way other than to say exactly that. Age function hasn't changed. Down here we're printing off somebody born April 12th, 1975 and then we use which generation to get that string that tells you the generation that you're from. And then we do the same thing with a couple of other dates. I got really fond of 12s for some reason. I'm not really sure why, but it happened. And so we will go with age and generation and run that. And we'll run that age and generation again. Here we go. So if you're born April 12th, 1975, you're 39, you're generation X, according to the algorithm I'm using to compute generations. September 12th, 1943, you're 70 and a baby boomer. I guess a baby boomer worked out in this case. And June 12th, 1990, you're 24 and you are generation Y. I want to take a look at another example of using a function. And in this case, using the return is going to do some make the algorithm a lot more efficient. So we're going back and looking at prime numbers and the number of primes. In this case, we're going to compute or decide whether a number is prime or not. This isn't the most efficient way to do this, but it is a method. So we pass in a number x, and we're going to return is prime, just returns true or false. It's not, that's it. So we check first to see if the number is greater than 1. 1 is not a prime number, so if it is 1 down here, we check for that and we return false. So we check if the number is greater than 1, and if it is, we go up to half of the number, starting from 2 to half of the number, and we divide x by all the numbers in that range, and check to see if there's a remainder. And if it turns out that there is a remainder of 0, then that means that whatever x is, it's divisible by I, and in that case, that means x isn't prime, and so we return false. But the nice thing about this is that means that we won't go through the entire range of numbers. As soon as this return is encountered, then this procedure will be executed. It says, oh, you found your value. I can only return one value, so it's going to have to be false. I'm done. So if you, for example, passed x into x equals 1 billion into is prime, then in theory you could be checking 500 million numbers, but you won't, because as soon as it takes 1 billion and divides it by 2, it's going to find out that 1 billion is divisible by 2, return false, and you're done that quickly, instead of having to go through 500 million iterations of this range. Okay, so now the other nice thing about this is, in this case, if we make it all the way through this and we haven't encountered anything that will divide into x, then this will execute and nothing will happen. And then we'll come down here to the last line, and in that case, we know that this number wasn't divisible by anything, so we can return true. We can say this is in fact a prime. Num primes is going to return the number of primes less than a given number. So we know 1 isn't a prime. We're going to start at 2. We start off with a count of primes less than a number as 0. And then we go from 2 up to, well, in range, you always have to go 1 over. So we go up to from 2 up to the number. And then we just check if it is a prime. If is prime, I in this range, then we found a prime number less than x, and we add 1 to our count, and then we just return prime count. And then this down here is just testing their code. So this gives us a way to test is prime and num primes working. So I'm going to test it for a range from 1 to 50. We pass in is prime, print out the number I, and if it is a prime, we say it's a prime number. Otherwise, we say it's not a prime number. And then we print out the number of primes less than or equal to I, and we print out num primes. Okay, so let's run that and see how we did. So 1 is not a prime number, despite what the movie Core said. 1 is definitely not a prime number. And the number of primes less than or equal to 1 is 0. 2 is a prime, and so there's 1 prime less than or equal to 2. 3 is a prime, so now there's 2 numbers, 2 primes less than or equal to 3, 2 and 3. 4 is not a prime, so prime count does not go up. In fact, prime count's only going to go up when you hit a prime. 5 is a prime. 6 is not a prime. 7 is. 8's not. 9's not. 10's not. 11 is, and so on. So it seems to work just fine. So just a couple of things. It's generally speaking, you probably want to write functions instead of procedures. It's just more versatile to pass back a value to the thing it's calling and let the thing that's calling your function make use of it however it needs to. And the other thing is using return values like this inside a loop or in other ways can often make your code more efficient. You may find out exactly what you need to know before the entire loop is done and say, you know what, I don't need to know anymore, I'm done. Okay, so happy coding.